Welcome to your second lesson in Chapter 16. This is Chapter 16, the crash course, Tolbert's class. All right, let's do another example. Here we have lithium, and here we also have oxygen. Simply, lithium just gives away its one electron. Oxygen is happy, right? No, that's wrong. Here's what happens. You need a whole nother lithium to make oxygen happy. Why? Because oxygen has an oxidation number of -2. So it requires 2 lithium for every 1 oxygen. Let's see how they get together. 1 lithium, 2 lithiums, and there you have it. Li2O. So, ionic bonds form between ions. These oxidation numbers are on your periodic table. We use the drop and swap method to write the formulas. Here you look at those numbers that appear up there, and you're going to move it to the bottom. Drop the charge, swap the number. Drop the charge, swap the number. Drop the charge and swap the numbers. This is how we get to lithium 2 oxide. Let's do the class examples. Once again, you should have these drop and swap numbers on your periodic table. So let's figure out the first one here. In this first one, it looks like I've got H and N. So what I need to know, if I've got an H, what is the charge of an H? Charge of an H is plus. What is the charge of an N? An N is -3. When we bring them together, I'm going to go H, get it a little closer, bring the N closer. I drop the charge, swap the number over here, but there's only 1, so I don't write a number 1. Here, I'm going to take the 3, and I'm going to bring it right down there. So my answer here is H3N. Notice there's no 1. We never write the numbers 1. Let's do the next example. All right. Let's see if we can make this a little bigger. So, in this example here, we have H and O. So if you know the charge of an H, the charge of an H is going to be positive. The charge of an O is going to be, as we did there, -2. If you drop and swap them, it should be what we know as water, H2O. Let's do another, Be. If you look on your periodic table for Be should have it should become the ion that is a +2. Nitrogen becomes an ion that is -3. So this number here is going to go to the back of the N. This number here is going to go right across. We're going to drop the charge, swap the number. So this becomes Be3N2. I do write the 2 because that denotes that it is more than 1. So those are some examples. In class, I may do more examples. Hopefully, you understand it. You drop the charge, you swap the numbers. So, polyatomic ions. Polyatomic ions. Polyatomic ions are just simply ions that have more than they are a compound that act together as a pair. Here you do the same drop and swap. If aluminum is a +3 and this carboxide has a -2, you're still going to drop and swap the numbers. Notice where those go. Review of the key concepts. Bonds are like flexible springs. Ionic bonds move electrons. Metallic bonds are sharing electrons. Covalent bonds are sharing electrons. And polyatomic ion is a molecule with a charge. You can use all these things to help you understand your periodic table, ionic bonding buddy, which is on the back of your periodic table, your brain, and some practice.